Good afternoon. My name is Uma Maheshwari. Here we'll discuss about the topic of PIC interrupts, which comes under the unit of PIC timers, serial port, and then interrupts unit, that is fifth unit. Here, what are all the types of interrupts? First of all, we'll just see that the interrupts will be just uh, divided into two types. One is hardware interrupts and next one is software interrupt. The hardware interrupts comes under the two categories of like maskable interrupts and the non-maskable interrupts. First of all, what is interrupts? The interrupts is the thing which is used to trigger the events that allows the microcontroller to pass its current task, and it can handle an event that is comes under an urgent manner, that is an emergency one, or else we can also set the such as an external pin changes or the timer overflows. This is the definition of the interrupt. First of all, you can enable the interrupt by setting the two types of interrupts. One is called as GIE, that is the global interrupt enable, and the next one is PIE, that is the peripheral interrupt enable. Global interrupt enable, the name itself we can say like it is a global one, like and then and optionally the PEIE, that is the peripheral interrupt interface interrupt enable will be using for peripheral interrupts. What are all the peripherals? Peripherals we can say like peripheral interrupts is nothing but you can also able to see the serial interrupt and then hardware part if it is any, and you can go for those kinds of interrupts. You must also set an individual enable bit also for the specific sources like INTE, that is for external INT 0 or external interrupt INT 1. These are all the two interrupts in the case of 8051 interrupts. Here, the flag bits, that is INTF, RBIF in the software also there in the case of interrupts. Here, why the interrupt latency? Before this, I have seen like what is the GAE, that is the global interrupt and all we'll see. The global interrupt enable is a bit 7 in bit 7 we can set as at a global interrupt enable. Here the master enable for all the unmasked interrupts. We have seen like in the previous slide we have seen the maskable and the non-maskable interrupts, right? So that is the unmaskable interrupts is the global interrupt enable. Here the PEIE, that is the peripheral interrupt enable, is a bit 6 1 we can able to enable if we need any peripheral interrupt one. Here, why this interrupt latency? The interrupt latency is you can have this interrupt controller over here, and you can see all those interrupts and all. These are all the device. Device is nothing but you can also have like that kind of LEDs, LCDs, whatever it may be. Here, the image itself you can see the interrupt if it is comes in the CPU interrupts are enabled, it is goes up means that it will just temporarily it will be stop the process of the microcontroller, and it will just obey the interrupts what it is getting into it, and then after finish of this it will just resume the old one. So this is the interrupts process. Here PIR 1 and 2 registers, or these registers contain the interrupt flag bits for various uh, interrupt enables. Like the next slide we can show, like this is the interrupt process. Like the process is nothing but here the peripheral pins, that is the process if it is comes in here, the interrupt vector table is there, the interrupt vector table and then interrupt service routine, these and all, like the time it takes for the microcontroller to start executing the ISR, that is the ISR is nothing but your interrupt service routine. Here, this interrupt service routine is also called as an interrupt latency. Here, the interrupt priority. Priority means what it will do is like while the PIC 16 of 877A supports the peripherals or an external interrupt, it does not have any strict priority systems within the peripheral interrupts. A peripheral interrupt will be handled only if it is a flag bit is set and it is an enable bit is set. Got it? And the next one is interrupt handling. Here restore process state enable bit. Here when the variable is shared between the main program and the ISR, that is interrupt service routine, it uses the volatile keyword which is in while you are just going for any kind of embedded C programming and all, it's there. No, if you're just instead of assembly language, if you're just writing embedded C means You will be using this volatile keyword in C to prevent the compiler optimizing that, and it might lead to an unexpected behavior. So this is the thing. Here the event occurrence, content saving, and then jumping to ISR execution, returning from interrupt, and then resume programs and all. We have discussed so far. Here, what are all the key components? These key components only we have seen in the previous slide. Interrupt service routine, vector table, enable bits, etc. Here, what is the interrupt? We have seen the word interrupt. So the thing is, while just you can go for any kind of LCDs or sensors or current sensor or any kind of serial communication or any kind of motors or temperatures, something like it is a temperature sensor and all, by using that temperature sensor, we'll be just displaying anything for that and all. The interrupt is a mandatory one, unless or otherwise, if you are just don't introduce any interrupt things and all, you'll be not able to check whether the you will be not getting the output correctly. Zigbee is the main thing you'll be using for any kind of communication. Here the CPU, program memory, data memory, and then EEPROM, for that and all, it is the core components we'll be using the interrupt we can use here. And the next one is the time delay. Why we are just mentioning the time delay? In the previous video itself, I have uh, seen like what is the time delay, what will it will be using. This time delay is the thing we'll be just setting for that particular interrupt. It should happen in a particular time period. For that, the time delay is necessary. Here, in the case of the sample code of this one, the oscillator selection bits, that is the HS bits, that is the pragma, two pragmas we have seen. One is the watchdog timers, and then the interrupts, that is IS, are also introduced here. And INTF is equal, if it is equal to 1, that is if we are just setting that particular interrupt pin is 1 means, then the port B will be enabled, and if it is not there, then the port B will be set to 0 here. The main program, your always the program execution starts from your main, and the port B is equal to 0. I have seen what for the 0 is we have just assigning, and then what for the 1 is assigning in the previous video. And GIE is nothing but your global interrupt. Then while we'll be using is, while of 1 is a continuous execution of a particular program unless it stops the execution thing. This is the application, that is improved responsive and then efficient processing and then modular design, security system, keypads. These are all the application of interrupts, especially in robotics, automotive systems. The interrupts plays a major role. Here, we'll just summarize what you have done. Just in the flow of the program, these are all the code memory, and then the thing of chip peripherals and then memory will be using this for this one. And this is a classroom activity for students. And assessment questions we have seen, like which registers used to enable or disable the individual interrupt sources, and what is the purpose of global interrupt, why it is necessary, and which of the following is an external interrupt. Here RB0 or INT is the interrupt. What happens when an interrupt occurs while it is in running? The current program, it will be passed and the program jumps to the interrupt service routine, that is called as ISR. That is what I have mentioned here, ISR here. These are all the reference I have taken. You can see the reference videos and the text contents and the images in more in this reference. Thank you. We'll see the next topic in the next video.